AI is absurdly expensive. I know this very well, but I am here to help you. It turns out there's actually a very straightforward and simple way to save 90+% on your AI bill. And I'm going to show you how to do it. Model routing. That is what we're going to be talking about today. Model routing simply means using the right model for the right task. And that is it. It's easy and it can save you a whole bunch of money. And if you like learning about how to save a bunch of money with AI, like this video, subscribe to the channel. So the main concept that I want you to learn today is the difference between planning and execution. You do not need the same level of model performance, of model quality for both of these concepts. So for planning, you're trying to figure out exactly how to do something. This is the really important part where you're kind of getting a sense of all the pieces of code that might be touching whatever you're thinking about building, how you want it to fit in, using best practices, and designing the architecture around the feature. This is very important, and thus you want to use the best possible model that you can for planning. But when you actually go to take that plan and write the code for it right here, you don't actually need a frontier model anymore. It turns out a good, cheap model can actually write code extremely well. So for example, for planning, you might use Fable, but for the actual writing of code, you might use GPT 5.5 or even 5.4. You might use Composer 2.5. These are models that are substantially less expensive than Fable. So planning, use the best possible model. Executing, use whatever model is good enough. So let me just show you the different steps of what my workflow looks like, and then I'm going to show it to you actually in practice. So first, we do the research, which we talked about. And you're going to be using a frontier model. Frontier is in blue, good plus cheap model is in green. So let's just say this is Fable and the good plus cheap is GPT 5.5. Now, I know GPT 5.5 is not quote unquote cheap as compared to like a Composer, but OpenAI is extremely generous with their quotas, especially for GPT 5.5. I'm considering it a cheap model. You can swap it out for anything you want. All right. And all the research gets done. You're using Fable. It's working with you. It's asking you questions. Okay, how do you want this feature designed? And what parts of the code base should we touch? And then when you finally come to a conclusion, you ask it to write you a spec right here. And that spec is going to also be written by Fable. And what is a spec? A spec is basically a document that details exactly how you want some piece of functionality or a full feature built out. Here's an example of a spec that was written for me by Fable, and it is, hundreds of lines long. Let's see, almost 600 lines long, and it really details the phasing of how this feature should be built. It talks about what the feature is for, how to build it, which is the most important part. And then you take this spec and you can give it to almost any model. A model that is just good enough at coding can take this spec and actually write all the code for it pretty effectively. And that's how you can save a ton. So after you do the research, after you have that spec written, you give the spec to the cheaper coding model and you have it write the code. And from there, when it's done, you have it create a pull request. Now, this step is optional, but I like to do it to have that frontier model really just check the work once more. And I have it review my PR. So I take the PR that was created by the cheaper, good coding model, and I give it back to Fable. And I just literally say, review this PR. Sometimes it has feedback, sometimes it doesn't. If it does have feedback, I copy that feedback back into the cheap coding model and I have it edit the PR. And then finally, I have that cheap coding model deploy the PR for me. And so you can start to see how this kind of back and forth between different models actually works. Now, there are some companies that do this for you automatically, and I'm going to get to that later. But for now, I'm assuming you're using Codex or Claude, and you can use both of them, or you can use one of them. All right, so let's say you're using Claude only. You would use Fable to do the research, write the spec, review the PR, and you can use, let's say, Opus 4.8 or even Sonnet, basically a really good coding model that is far cheaper than using Fable for everything else. Now, if you have 2 subscriptions, and even if they're the $20 or $100 a month subscriptions, you're going to be able to get so much more out of them before upgrading to the kind of that next subscription plan. And even if you are on the top tier, the $200 a month plan for one or both, this strategy that I'm describing will help you kind of regardless of what subscription you're paying for. And if you like saving money on AI, check out the sponsor of today's video. GenSpark is an all-in-one AI workspace. It's not just, okay, prompt, and then it's going to give me an answer. Then I have to take that answer and paste it somewhere else. You actually get all of your work done right from GenSpark. So let's say you have a product idea. You can use AI slides to develop your pitch deck for it, use the AI designer to develop the visuals and brand identity, GenSpark code for actually coding the landing page, and AI video for making a short promo. And GenSpark is especially useful because it brings all of these tools and all of the models into one place. So you're not bouncing around different apps, different websites. It's just all in one place, making everything seamless. And if you're a new user, you can get the Get Started bonus. Paid plans have unlimited AI chat and AI image through 2026. A huge value. Use GenSpark to go from initial idea all the way through usable product, fully promoted, all with GenSpark. And if you're a new user, you get free credits. So go check out GenSpark. I'm going to drop a link down below. Now back to the video. All right, so let me actually just prove the math to you. Let's say we're using Fable as the frontier model. It's very expensive. It is $10 per million input tokens and $50 per million output tokens. And that's really important to notice. The output is 5 times more expensive than the input. And now maybe you're starting to see why this strategy pays off, because if you're doing research, you're reading a lot of things. Whereas if you're writing code, you're outputting a lot of things. And so the research phase uses far fewer output tokens than the actual code writing. So if we're using a cheap model for code writing, which we're showing right here, $2 per million input tokens, $6 per million output tokens, the total cost of building a feature, building a product drops substantially. All right, so let's go through the math. We have planning that is going to use 100,000 input tokens and 20,000 output tokens. Then we have coding, which is going to use 150,000 input tokens, but look at this, 120,000 output tokens, because it actually has to write all of that code. And yes, coding also uses more input tokens because it's reading code, it's writing code, it's doing everything. The planning phase actually uses generally far fewer tokens than the actual execution phase. And so let's say we're doing our planning with Fable. We have 100,000 input tokens multiplied by $10 per million input tokens, which is $1 right there. Then we have 20,000 output tokens multiplied by $50 per million output, which gives us another $1. Total cost, $2 for planning. And keep that in mind here. Now, if we continued to code with Fable, so this is not offloading the coding to a cheap model. Let's just do the comparison. We're not only planning, but we're also coding with Fable. 150,000 input tokens times 10 is $1.50. Then we have 120,000 output tokens times 50 is $6. Total coding cost of $7.50. Then if we sum our planning and our coding costs, the total cost is right here at $9.50 for whatever we just built. Now, let's look what happens if we start to offload that coding, the execution phase, to a cheap model. So we're going to assume the planning stays the same with Fable, but we're going to offload the coding to a cheaper model. We have 100,000 input tokens times $2 instead, which is 30 cents. We have 120,000 output tokens times $6, which is 72 cents, for a total cost for coding of $1.02 compared to $7.50 with Fable. Now, because the spec, the planning had already been done, all that the cheaper, less capable, but still very good at coding model needed to do was just look at the plan and write the code, which it is totally able to do. Now, the total cost, $3.02. That is as compared to $9.50, a $6.48 savings, also about 68%. A 68% savings, which is incredible. you're going to be able to take your quota and stretch it so much further than you would otherwise. If you're already paying for API calls, you will be able to stretch your budget so much further than you ever had before just using this simple idea. All right, but enough hand waving. How do you actually implement it? How do you actually do this? Let me show you. So the first way I want to show you how to do this is actually the easiest but most manual way. Let's say you have two subscriptions, one for OpenAI and one for Claude. You want to use Fable for your planning and you want to use GPT 5.5 for the actual writing of code. So this is what I did. I went back and forth with Fable, deciding exactly what I want this feature to look like, which uses very few tokens. And then finally, I had it output a full spec. And this is, hundreds of lines of exactly how the feature I want built should be built. So what do I do with that? Well, I simply copied it. I typed build this, and then I pasted in the spec. The full spec is right here. Exactly how Fable would have built it. Now I have a much less expensive model building it with GPT 5.5. So it spent almost an hour in total building out this feature. And so what did I do after that? Well, it created a PR. I took the PR and I simply went back to Fable and said, review the PR. And so it did. It wrote a few pieces of feedback, nothing too critical. Then I pasted the feedback back into Codex and said, just fix these issues, then deploy. And that's my entire process. Literally just copy pasting from Claude to Codex and back and forth. And with that, I probably saved about 60+% of my quota usage. But there are easier ways to do this. And one thing I found to be really neat is the fact that Claude Code can actually call Codex. And Codex can call Claude Code. They can actually call each other from within itself. All right, let me show you the actual skill that I've developed. It's very simplistic, but it basically just says plan with Fable, delegate to Codex, GPT 5.5 for the actual writing of the code. And it's exactly what we just went over. So here's the skill. Fable plans, GPT 5.5 Codex writes, Claude verifies, and it just maps out exactly how to do it. The nice thing is that Codex has a CLI, which is a command line interface. It basically just means that Claude can execute it just like any other piece of code. And so it'll execute the code writing with Codex, wait, get the code back, and then just integrate it into the actual feature. So when you're ready to use it, you just do /codex implement, type out the feature that you want, and then you're done. And it's gonna plan with Fable, delegate out to Codex. Now, besides for Claude and Codex, there are other agentic coding harnesses that are model agnostic, meaning they are not owned by one of these frontier labs. Now, the good thing about using one of those is you can use models from any of the labs and open source models. You basically can pick any model that you want, and it's all in one interface, which is really nice. And here's the other thing. The frontier labs like OpenAI with Codex, like Anthropic with Claude Code, they do not have model routing. They are not really incentivized to do model routing. Why would they? They want you to use Fable. They want you to use the top tier model. However, all of the third-party harnesses like Cursor, like Factory, like Devin, all of these have spent a lot of time on model routing because it is a differentiation for them. They have more types of models available. Thus, they have more options to choose from for what task goes to which model. So for example, in Cursor, they have auto mode. You simply turn it on and it will route your task to the appropriate model. There's not a ton of visibility in how it actually routes, but I've heard it's pretty good. And in fact, if you choose a frontier model in Cursor, oftentimes it will route what it knows to be easier tasks to Composer 2.5. Composer 2.5 is Cursor's own homegrown, really good coding model. And so you can see that here. I am using Fable 5 High, but it spun up a bunch of sub agents that it delegated out work to, and those subagents are using Composer 2.5 fast. So these things become especially important when you want to use all the different models, you want to use them all in one place, and cost efficiency is important to you. So obviously, if you're an enterprise company, this becomes majorly important. Then you have companies like Not Diamond, and I'm a small investor, so disclosure there, which all they do is model routing. This is what they do really well. And this is great if you're an enterprise company with a large budget. And you not only save a bunch of money, but oftentimes you actually get higher quality results. But here's the thing, I don't want you to only think about model routing when it comes to coding. Not all of you are doing coding. Maybe some of you are using Claude Cowork, which is, you're creating documents and Excel files and you're doing knowledge work. It's just not coding. You should also be thinking about which model that you're choosing. Don't always use whatever shows up in this box. Click into it. Figure out what each of these models is good at. You have Haiku 4.5, which is extremely fast and very cheap, obviously not as capable. You have Sonnet 5, which is a little bit cheaper, still very good. You have Opus 4.8, which is kind of the previous generation model at this point, but still very capable, relatively well priced. And then you have Fable, the best of the best, the most expensive. Get to know these models, get to know what they're good at, where their capabilities fall short, which types of tasks do well with each of them. Don't just go with the default. I cannot stress that enough. And not only that, not only choosing the family of models, you should think about the effort level, which is found right here. Every single one of these platforms, Codex, Claude, even ChatGPT directly, they all have this thinking setting, and you can have low thinking all the way up to max thinking. And the harder the problem, the higher thinking level that you want to apply to that problem. But you don't need max thinking for most problems. In fact, they default to high. If you're doing something as simple as deploy this code, you can get away with using the lowest thinking level. So get familiar with the models, get familiar with the model families, get familiar with the thinking levels. And the last thing I want to talk about is how important this is as you scale up. If you're an enterprise company and you have millions of dollars in spend per month on AI, and that might only be a very small percentage of you out there, but if you do, this problem becomes much more important to think about. Here's Brian Armstrong from Coinbase. Coinbase, one of the kind of most AI native companies out there nowadays, has shown while their total token usage, which is this black bar, continues to increase, the actual bars right here are decreasing. This is their total cost decreasing or staying flat. And the way that they were able to do that is by exactly what I've told you throughout this video, routing the right task to the right model. And they've even integrated cheap open source models like GLM 5.2. So you have this incredibly capable, very efficient, very cheap open source model that they are using to do the majority of coding tasks. And they're probably using their frontier models from OpenAI and Anthropic for the actual planning. Now, they take it even further. They have better caching. They have context management. They kind of manage their defaults, the default thinking effort much more aggressively. And maybe that's going to be in another video. And so now that you know all about model routing, you should take all of that knowledge and go do some vibe coding. I talked about it right here.